This is our video for Advanced Math, Unit 8, Lesson number 4, and we're going to be talking about our special triangles. And understanding and learning these two special triangles is very critical to success in trigonometry because so much is based off of knowing and understanding what goes on with these two triangles, especially as it refers to right angle trigonometry. All right, so let's go ahead and get into it with our first one. As we can see here, we're talking about a 45, 45, 90 triangle. And what we have is an isosceles right triangle. All right, so since we have a 45, 45, 90, we know that these two angles are congruent, both 45 degrees. And because those two are congruent, we also know by definition those two sides are congruent. So what we're going to do here is, since we know that those two sides are congruent, looking at step 2, we're going to say that each one of those sides is 1 unit long, and we don't know what the length of our hypotenuse is, so we'll call hypotenuse C. Now, our good friend Pythagoras figured out that in a right triangle, the sum of the squares of the two sides, so 1 squared plus 1 squared, those are the two sides, the two legs of the triangle. The sum of those squares is going to equal the hypotenuse squared. Well, 1 squared plus 1 squared is just 1 plus 1, so 1 plus 1 equals c squared, which means 2 equals c squared. And then once we take the square root of both sides, we get square root of 2 equals c. And what we have here is a ratio. There's a ratio of the side lengths where we have 1 square root of 2. So now we can take that c out of there since it's no longer unknown, and we know that it is equal to square root of 2. And that ratio holds throughout every 45, 45, 90 triangle. That ratio of side lengths 1 square root of 2. Now what we want to do next is get the trig function ratios for our 45, 45, 90 triangle. And because the two non-right angles are congruent, either one of them can be theta. And so what we're going to end up with is we're going to have sine 45 degrees, or pi over 4. Sine 45 degrees is, and it doesn't matter which one because they're congruent, opposite over hypotenuse. So 1 divided by the square root of 2. But wait a minute, we cannot have that irrational number in our denominator. So we've already looked at rationalizing denominators, so that is equal to square root 2 over 2. Now let's look at cosine. Cosine 45 degrees. Again, since they're both equal, the adjacent angle is, or the adjacent side length is 1, so we have 1 divided by square root of 2, which, as we saw with sine, is equal to square root 2 divided by 2. Now let's look at tangent 45 degrees. Well, tangent, opposite over adjacent. So there we have sine 45 square root 2 over 2, cosine 45 degrees square root 2 over 2, and tangent of 45 degrees is 1. So next we want to look at our other trig functions. So we have cosecant 45 degrees. Well, now we're looking at our hypotenuse over opposite, square root 2 over 1, square root of 2. Secant 45 degrees, again we have square root 2 divided by 1, square root 2. And cotangent 45 degrees, adjacent over opposite. 1 divided by 1 equals 1. So that is something there. Those those 6 values there you need to memorize, or actually don't have to memorize, but just understand the concept, because you can always go back and set up your 45, 45, 90 triangle. Really all you need to know and understand from this is the 1, 1, square root of 2, and then you can always, as I said, go and set up that triangle. And as long as you know those ratios, side length ratios, 1, 1, square root of 2, then you can go in and get sine, cosine, tangent, cosecant, secant, and cotangent from the ratios, from those angles, opposite over adjacent, and all that good stuff. So there we have it with our 45, 45, 90 triangle. Now let's move on to our second special triangle. Our 30, 60, 90 triangle. Now with our 30, 60, 90, what we're going to do is we're going to start with, as we see there, an equilateral triangle. And we know for equilateral, that means our 3 side lengths are all congruent. So we want to label them as congruent. And as we know from geometry, an equilateral triangle is also going to be equiangular. So we can go ahead and label those 3 congruent angles. Now, again, going back to our geometry, we know that the 3 angles have to sum to 180, and since they're all equal, we know that each one is going to be a 60-degree angle. So now what we're going to do is say we're going to define each one of our sides to be 2 units long. They're all congruent. Each side is 2 units long. Now, going on to step 3, we want to draw a perpendicular line segment from the top to the base. So let's get in a perpendicular line segment here. And again, by geometry, when we do that, it bisects the angle and it also bisects the base. So now we know that we have two 30-degree angles right there. So that creates congruent 30, 60, 90 triangles. And because we bisected the base, we know that that is 1 and that is length 1. And so what we created, let's pop this out over here and we'll pop it out, make it a little bit smaller. We now have created a right triangle. Our bottom, our base, has a length of 1, and our hypotenuse and our hypotenuse is length of 2. And again, there's our 30-degree angle right there and our 60-degree angle right there. Again, understanding that all I did there was take that triangle right there and pop it out by itself. Now, going back to our good friend Pythagoras, we need to find out what is the length of that altitude there. And let's go back over to the left side with our notes. All right, so we have the triangle has hypotenuse length of 2, and the shorter side length, our base, has length 1. So now going back to, we'll call this B. Going back to Pythagoras, we know that 1 squared plus B squared equals 2 squared, so that 1 plus B squared equals 4. Meaning B squared equals 3, so B is equal to square root of 3. So we have 1, 2, square root of 3. And that ratio is going to hold for all 30, 60, 90 triangles, a ratio of 1, 2, square root of 3. And the thing you've got to remember is that the hypotenuse is twice as long as the side opposite the 30-degree angle, not the side opposite the 60-degree angle. So just because the 60-degree angle is twice as much as the 30-degree angle, that does not hold true for the side length ratios. It is the hypotenuse that is twice the length of the shorter side. All right. So now let's go ahead and look at our trig functions for our 30-degree angles and our 60-degree angles. And we'll start with the 30 degrees. So sine 30 degrees. All right, sine of 30. So looking at our 30-degree angle, all right, the sine opposite over hypotenuse, 1/2. Cosine of the 30-degree angle. Now the square root of 3 is the adjacent side, so that is square root 3 over 2, and our tangent. Tangent 30 degrees, opposite over adjacent, 1 divided by square root of 3, which is square root 3 divided by 3. Now for our cosecant of 30 degrees, hypotenuse divided by opposite, 2 over 1. Secant 30 degrees. Now we have hypotenuse divided by adjacent. So 2 over square root of 3, which we have to rationalize out to 2 square root 3 divided by 3. And our cotangent, 30 degrees, adjacent over opposite, square root 3 divided by 1. And again, you can memorize all 6 of those, which isn't really necessary because really all you need to do is memorize the 1, 2, square root of 3 side length ratios from the 30, 60, 90. And from that, we can derive or we can compute out our trig function ratios. And as we can see, all of this is non-calculator here. A lot of trigonometry is non-calculator. All right, so now let's look at our 60-degree angle. Drop this down just a little bit. All right, sine of 60 degrees. Now looking down at our 60-degree angle, we've got opposite over hypotenuse, square root 3 over 2. Cosine is 60 degrees. All right, looking at our 60, adjacent over hypotenuse. And tangent. Tangent 60 degrees, opposite over adjacent, and we see square root 3 over 1, so I'm just going to go ahead and put square root 3. Now for a cosecant 60 degrees, hypotenuse over opposite, 2 divided by square root of 3, So 2 square root 3 over 3. Secant 60 degrees. Hypotenuse divided by adjacent, 2 divided by 1. And last but not least, our cotangent 60 degrees. We're looking at adjacent over opposite. So now we have 1 over square root of 3, which is square root 3 over 3. So those are the 2 special triangles and the 18 trig functions that go along with the angles as far as the side length ratios in getting our trig functions. All right, that's it.